previous video we actually worked out how to calculate this using matrices, so we'll go straight into it. So what we did in the previous little video is so that A cross B will be the determinant of a 3 by 3 matrix which has got I, J and K as its first row. Then it's got the components of the first matrix. Now the first matrix, we've got no I, so it's like 0 I. So it'll be like 0, 7 and 2. And the last row is are the components of the second matrix. Now we got 2 and we got 0J there, so it'll be 2, 0, 3. Alright, so we want the determinant of that matrix. Now we put a plus, a minus and a plus across the top to remind ourselves that this one's going to be a negative. So we've got plus I, and it's I is in the first column and in the first row, so the elements that are left are 7, 2, 0 and 3. Minus J, we're moving across the top row. J wipes out the centre column and the top row, so we've got 0, 2, 2, 3, plus K. Now K takes out the last column. Once again it takes out the top row, so we've got 0, 7 and 2, 0. We can now calculate the determinant of a 2 by 2. So we've got I. We do the leading diagonal first, 7 times 3, minus, always minus, 2 times 0 or 0 times 2, minus J, 0 times 3, minus 2 times 2, plus K, 0 times 0, minus 2 times 7. So it's that times that, minus 2 times 7. Equals, this will be 0, 7 3 is 21, so 21I. That's 0, and that's minus 4. So minus 4 will give plus 4. And that's 0 minus 14, so it'll be minus 14K. So this vector is the resultant of A cross B when you do the cross multiplication of vector A, which is 7J plus 2K, and vector B, 2I and 3K. When we do the cross product, we end up with this vector. What would happen if we do vector A, which is 7J plus 2K, dotted with this? Have a think about that. What would you expect our answer to be? Put the K there. When we dot one of these vectors, A, and this resultant. The dot product, if the dot product is equal, well, let's go back another step. What do you know the relationship between this vector A and this resultant vector when we get the cross product? You know that this must be at right angles to those vector A and B. So the way to check for something being perpendicular at right angles to each other, two vectors, is if the dot product is equal to 0. then the two vectors are perpendicular. So let's just test to see if these two vectors are indeed perpendicular to each other. Now the dot product's the easy one to do. We just multiply the I components together, the J's and the K's, and add them all up. Now there's no 0 I here, so it'll be 0 times 21 plus 7 times 4 plus 2 times negative 14. 0 times 21 is 0, plus 7 4 is 28, minus 28, and we get a number of 0. So that shows that vector A and this resultant are perpendicular to each other. Similarly, if you really wanted to, you could show that vector B, dotted with this vector, would also be equal to 0, showing that those two are perpendicular as well. Alright, so this is just an example here of how to calculate the cross product using matrices, and we have used something you need to commit to memory, which is that, and then to be able to go through and calculate. So this vector here is the resultant answer being the cross product of vector A and vector B.